Hi students, welcome back to another unit in algebra. This unit will be studying systems of equations and we'll be working with linear equations. So we're going to pull back in some of that information from chapter 3 and 4 when we talked about how do you graph an equation of a line. We'll be reminding ourselves about slope and y-intercept. So let's go ahead and get started today. Today we're going to start by reviewing our essential question, which is how can I use a graph to find the solution to a system of two linear equations? All right, so to begin, we're just going to talk about some background information. So first question is, what is a system of equations? Well, a system of equations is two or more equations. So it's two or more equations. Now, these don't have to be linear, but we're going to stick with linear for right now, that work together to create a solution. So if you think about it, a system works if there's a process in place and you stay in order. And so that's why we call it a system of equations. They're working together to come up with a solution. Awesome. All right, next up. How can we solve a system of equations? Well, there's actually three ways we're going to learn about over the next bit of time. The first is the one we're going to talk about today, which is graphing. You can find a solution to a system by graphing. The second method we use is called substitution. Think about a substitute teacher. There we go. And then the third method that we use is elimination. Elimination is going to be the one where you eliminate a variable. There we go. All right, so we have these three methods. Today, though, we're going to be focusing on the first of these three, so we're going to be looking at graphing. All right, let's take a look at our first example together. So in our first example, we are going to be graphing these two. Notice this is considered a system because we have two equations listed. I'm going to always start by listing out what is my slope and what is my y-intercept, and then we will plot that on the graph. So in this case, if you remember, your y-intercept is the number that is just by itself. It doesn't have the x attached to it. So in this case, that's -1. And our slope is always attached to the x. So in this case, that's going to be 2 over 1. So if you remember, slope is rise over run. So this tells us to go up 2 over 1, and we always are going to go over to the right. So I'm going to start at -1, putting a dot, and then I'm going to go 1, 2 over 1, up 2 over 1. And I can do this as many times as I need to in order to get to the point where I can see the line clearly. Now with systems, when you're graphing them, I find that the more points you plot, the easier it is to see the intersection. Now that's just my opinion. Other people might have other opinions, but like I said, I really do feel like when you plot a few more points, it really does help. And then just drawing a line through those points to make sure that we've connected all the dots. All right, let's take a look at the next one. So in this equation, again, we're going to start by identifying both the b and the m, or the y-intercept, which is the number by itself. This time that comes first, so -5. And then the slope of this line is 3, or 3 over 1. So again, I'm going to go to my graph and I'm going to start on the y-axis because b is the y-intercept. I'm going to start at -5. Just going to double check that. 1, 2, 3, 4, 5. Yep. And then I'm going to go up 3 over 1 because remember, slope is rise over run. Up 3, 1, 2, 3 over 1. And I just keep doing that. 1, 2, 3 over 1. Now it looks like it's crossing, but it didn't match up perfectly with the dot. So we're going to do it one more time. 1, 2, 3 over 1. Aha. Right up here, that's where they're crossing. So I'm going to go ahead And I'm going to grab my line tool. I'm going to make sure it's orange so that it matches up with the color of my dots. And I'm going to draw a line through it. All right, so now we're ready to state the solution. The solution to a system is the point where they intersect. So in this case, I need to figure out what are the coordinates of this intersection. And coordinates are determined by how far over we went on the x and how far up we went on the y. So in this case, we have 1, 2, 3, 4 over, 1, 2, 3, 4, 5, 6, 7 up. So I would say my solution is 4, 7. And I can state that over here if I want to, so it's a little easier to read, but I wanted to make sure I showed you on the graph where I was getting that from. Awesome job. Let's go ahead and take a look at another one. All right, here in example B, we have another system of equations. I'm going to go ahead and begin by looking at my first equation. It is in slope-intercept form, so I can state the slope and the y-intercept just by looking at the equation. Sometimes we will have to do a little work before we can do that, but in this case, we're good to go. We can just jump right in. So in this case, my y-intercept is 5, and my slope is attached to the x. So that's -2, and if it doesn't have a number below it, we put a 1. So in this case, this one's going to go down 2 over 1. All right, so starting at 5, 1, 2, 3, 4, 5. Notice I'm starting on the y-axis because it's a y-intercept. And then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And I can keep going and doing this as many times as I need to. Again, I find it best and easiest for me if I do more points because it helps to make sure that I can clearly see where they cross. All right, I'm going to use my line tool, draw in my straight line, and then we're going to jump back over and we're going to do the same thing with the next equation. So again, I'm going to make sure I state my b value, which is my y-intercept, and my slope. Well, my b value in this problem is -2. That's where we start. And my slope is, again, the number attached to my x. So this is going to be 1/3. So I'm going to go up 1 over 3. So starting at -2 on my y-axis, I'm going to go up 1 over 3. Oh, sweet. It matches up right away. That makes my job a lot easier. I don't have a whole bunch of extra plotting I have to do. So again, I'm going to grab my straight line tool. I'm going to draw a line through it. Don't be afraid to draw a line through more points, or if you need to, extending those lines. Sometimes you're going to feel like, am I doing it right? But you are. You just have to trust the process. So now we're ready to state the solution. And in this case, the intersection is happening right here. So that's where our solution is. And again, we go to the x-axis first and we say we went 1, 2, 3 over and down 1. So I would say my solution is 3, -1. Or the coordinates where it crosses is 3, -1. Now, keep in mind, I'm giving you 2 values of where the solution happens. Like a treasure map, you got to have both directions in order to make sure that you know where you're headed. And so as we move forward, remember, we're going to need both an x and a y value when you're solving a system using those other methods. Let's move on to the next page. All right, example C, again, I start by checking, is the y value by itself? And in this case, it is. And we go ahead and begin by identifying the b value and the slope or m value. B in this case is 4, and the slope is 1/2. All right, go ahead, plot these points, see if you can plot the line, and then check it with mine. All right, so we're going to start at 4 on the y-axis, and then we're going to go up 1 over 2, up 1 over 2, up 1 over 2. Now, I've always been going in the positive direction. I could also reverse this and go down one and go to the other direction. But when you do this, remember your points should still all line up. All right, so I'm going to go ahead and connect these dots with a straight line. If you need a straight line, you can just fold your paper over and you can use the edge of that. And we'll go ahead and plot the next points. So on the next equation, we have to identify the m and the b. So the b value here is the number by itself, -5, and the m is 2. And again, it's not written as a fraction, so I always write it over 1. And if it helps, go ahead and put those symbols. So up 2 over 1 just helps give you that visual cue of where you're headed. All right, so starting at -5, we have 1, 2, 3, 4, 5. There we go. And then we're going to go up 2 over 1, 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 up 2 over 1. So we had to trust the process. That one we had to go a very long distance before we saw that it was going to overlap. Grabbing my straight line tool. Again, you can see they are overlapping right here at that point. So next up, we just have to come up with our solution. Take a second, see if you can determine where is or what are the coordinates of the solution or the spot right here. All right, let's see what we got. Did you get 6,7? If you didn't, double check your counting. Also, remember the x distance goes first and the y distance goes second. So from the origin or the 0 in the middle, we went 6 to the right and up 7. Awesome job. All right, we've got 2 more examples for us. On the next example, we're going to start off with having to do a little bit of work up front. So notice in this equation that y is not by itself. And so in order to get y by itself, I'm going to need to do a little bit of work. So we have 2y equals 10x plus 6. I need the y to be by itself, and in order to do that, I need to divide everything in my equation by 2. Now I have 10 divided by 2, which is 5x, plus 6 divided by 2, which is 3. Now that y is by itself, I can clearly identify what is my y-intercept and what is my slope. In this case, my y-intercept, or where I start, is 3, and my slope is 5 over 1. Right, so I'm going to go ahead over to my graph. I'm going to start at 3, and then I'm going to go up 5. 1, 2, 3, 4, 5. I'm a little off the graph, over 1. So I'm also going to go down 5 and over 1, just to make sure that my line is able to be seen pretty clearly. And then I'm going to go ahead and connect those dots or points. When I connect those points, I get this line. All right, next up, let's take a look at the next equation. In the next equation, I notice that I have, again, y is not by itself, but this time to get y by itself, I need to add 5x to both sides. All right, when I do that, I get y equals -1 plus 5x. So I'm going to go ahead and start at -1. And I'm going to go up 5. 1, 2, 3, 4, 5 over 1. Now, notice that if I go and connect these points, they're going to have lines that are running right next to each other, but they're not going to be able to cross. I'm wondering, do you know why this is? Why would these lines never cross? And hopefully you're saying, hey, Miss Vernon, those are parallel lines. And parallel lines occur when we have the same slope. So notice that the slope of both of these lines are the same. If parallel lines go side by side but never cross, then we can't have a solution. So in situations like this, we say the answer is no solution. The reason we say the answer is no solution is because, hey, they don't cross. So we're out of luck. All right. Got one more question for you. And this one is a challenge question. So in this case, neither one of my equations have y by itself. So I'm going to go ahead and rewrite the top equation over here. And we're going to have to get y by itself by doing some balancing. When I go to get y by itself, I'm going to begin by subtracting 2x from both sides. Again, this is meant to be a challenge question. So stay tuned, work it out with me, and we'll get there in the end. Next, to get y by itself, I need to divide both sides, or all terms, by 4. When I do that, I get y equals 5 minus, and I can reduce 2 over 4 to 1 over 2x, or 1/2 x. All right, now that y is by itself, I can identify my y-intercept as being 5, and my slope, or m value, as being negative 1/2. Remember, when the slope is negative, it means we go down 1, and we always go over to that right 2. So plotting these points, I'm going to start at 5. 1, 2, 3, 4, 5. And then I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. And I just keep repeating that process so I can see all those points clearly on my graph. Next, I'm going to connect those points with a straight line. Again, I find just using the edge of my paper is helpful if I'm doing this by hand. All right, first line graphed. Now we're ready to take a look at the next equation. So in the next equation, as I work my way through solving it, I'm going to do a similar process. I need to get the x to the other side so I can isolate the y. I'm going to do this by adding 3x to both sides because it undoes. Next, I'm going to get the y by itself by dividing every term by 6. When I do this, I get negative 3 plus 1/2 x. Now I can clearly see that my b value is negative 3 and my slope is 1/2. So again, slope of 1/2 means that I'm going to go up 1 over 2. So I'm going to go ahead and start at negative 3. And this was a positive 1/2, so I'm going to go up 1 over 2, up 1 over 2. And I just keep repeating that process. And in the process of completing it, I see that my lines do end up overlapping. They're overlapping at this point right here. So now I need to determine the coordinates of that point because that is my solution. Go ahead, see if you can identify what are the coordinates of this point. 1, 2, 3, 4, 5, 6, 7, 8, and up 1. So I'm going to say my solution is 8, 1. Now, did this problem require a little bit more work? Absolutely, but it combines our skills of solving from our first unit of study and our skills of graphing from our second unit of study. As you can see, math builds, so it pays to understand what we learned before. Have a great day. I hope you understood the lesson, and we'll see you soon.